Hello, my name is Molly Ilovich, and this is my lesson for CS 5704. I will be giving an overview on some of the top 10 application security risks according to OWASP, the Open Web Application Security Project. OWASP is an open community dedicated to keeping applications trustworthy. So what is an application layer attack? It is described as a malicious attack on the top layer of the OSI model, surprisingly called the application layer. The application layer is the only layer that the end user interacts with in regards to communications that take place in computer systems. Due to this, it is the layer that a software engineer needs to plan to protect against cyber threats. According to Cisco's annual report for 2019, attacks on the network layer are actually falling, and threats to the application layer are increasing instead. This is due to the focus that organizations put on protecting the network layer, while less thought is put into scrutinizing the application protocols. It is also rising because of the Internet of Things. More devices with software are being put onto networks, and they are more vulnerable with these types of attacks. There have been many vulnerabilities found at this level in the last several years, and in 2018, a Marriott data breach was found which went unnoticed due to poor software design. I will discuss in this video the type of application vulnerability that occurred for this breach to cause as much damage as it did, along with other threats OWASP has deemed necessary to protect against in its 2017 report. First up are injection flaws, like SQL injections or LDAP injections. These occur when hostile data is sent to the language interpreter and it tricks it into executing unintended commands or accessing data. The diagram in this slide shows a very basic example where this very intimidating hacker puts a special string into the password field of the login screen. This string tricks the server into granting this person access to its data despite him not having the correct access. Obviously, injections used to hack larger pieces of software would need to be a bit more sophisticated, but a person can figure out these tougher injections. That is why it is up to a developer to figure out ways to guard against it. There are options when it comes to protecting your program against these particular cyber threats, but the preferred one is to use a safe API to keep the data separate from the commands and queries. Another way is to use a server-side input validation to act as an extra guard against injections. Dynamic queries can also be protected by escaping special characters, which makes the expression able to query and easier to guard. Using limit and other SQL controls within your queries can also be used to stop mass disclosure of records. That one is not the preferred method, since it still leaves a program vulnerable, but can be used as a quick fix. Application functions that have to do with authentication and session management are often implemented incorrectly according to OWASP, and they allow a hacker to assume the user's identity when logging into a server. The diagram on the slide shows a simple example of someone exploiting an unencrypted connection between a client and a server. The unsavory fellow uses a packet sniffer to gain the session token of the legitimate connection and uses it to gain access to the unsuspecting server. This is only one example, and a software developer must keep in mind protections when using any kind of authentication and session management in applications. Multi-factor authentication being implemented wherever possible is a good way to prevent multiple broken authentications, like brute forcing and stolen credentials. A seemingly obvious way to prevent someone from breaking into your application is to make sure it is not shipped or deployed with default credentials, since they are very easy to figure out. Along the same line is implementing a weak password check and having the check follow the proven password policies that exist when a user is creating their credentials. So stopping passwords that are just the word password or other way too simple examples. On top of not allowing weak passwords, a developer should consider limiting the number of failed login attempts, depending on how sensitive the information that is being accessed is. To protect sessions from being stolen, a secure server-side session manager can be used to keep them constantly changing and secure. Broken access control is a very easy vulnerability to avoid because it comes down to giving the appropriate users the correct privileges, but these are not always properly enforced. This can be due to an administrator being lazy, but it can also be protected against by the developer. There are certain things that a developer of a program can do to make sure access control is followed, and testing the rules thoroughly is one of them. This is normally overlooked, however, because it is hard to create automated tests for this. It is often a heavily manual process. The preventions I'm about to go over are worth nothing if access is not effectively controlled by trusted server-side code or a serverless API within your system. This is because if it is not, a hacker can just get into the system and change his role to anything he would like. This would make any secure roles you have created useless. The most obvious prevention is denying access by default in a program. Make the administrator give out access as it is needed, which results in less people having full control of a system. Another way to protect access is to enforce record ownership so only specific users can manipulate certain records. Logs and alerts are also very important to program around access control, so failures can be found and dealt with quickly. Limiting API and controller access is another effective way to prevent broken access control because it will minimize the harm of an automated attack by only allowing a certain number of attempts. All of these preventions are effective only when QA teams and developers create tests for them, however. Like I mentioned in my previous slide, testing access is the main way to prevent someone harmful from gaining too much control.
According to OWASP, the main reason that large data breaches, like the Marriott breach mentioned earlier, are allowed to occur is due to insufficient logging and monitoring. That means that events that are caused by attackers are not kept track of anywhere, or if they are, nothing is actively looking out for these potentially harmful events. This lack of logging or monitoring is very often coupled with ineffective incident response by the organization, which leads to a breach going unnoticed for far too long. An incident response should be the organization finding an attacker and shutting it down quickly. This obviously did not happen within the Marriott breach because lots of data was taken by the attackers and it was all over the news.
So, according to most studies, what is the average amount of time it takes for an organization to discover a breach after it occurs? Take 10 seconds or pause the video to try and come up with the amount of time. So did you come up with an amount of time that you deem acceptable for a large organization to be unaware of ill-intentioned people in their data? If you did, then you may be surprised that the answer is an average of 200 days. The length of time that breaches are allowed to go on for is the reason that so much harm is caused by them. If developers improve logging and monitoring within their programs, then breaches are less likely to happen and continue. However, this needs to be paired with an effective incident response plan that is made by the organization. To prevent breaches from going unnoticed, a developer must make sure to create logs on harmful events that are easy to understand and held for an appropriate amount of time. This allows administrators to spot any discrepancies that happen within the programs they monitor and deal with them as they see fit, or hopefully the incident response plan tells them to. Not only should harmful events be logged, but any important events should have an audit trail that no one can alter. Allowing your logs to be altered after an event has occurred creates the ability for anyone to do anything unnoticed. For example, Pan can send Jim $100 from her boss's account and just go into the logs and erase them, making what she did basically untraceable. So audit trails are very important for reasons like this. Making logs easily consumed by a log management solution like Splunk is a simple way to keep your application easy to monitor. Having a log management solution streamlines into having effective monitoring and alerts, but a developer can create her own if she wants. Just buying one off the shelf can be easier for some organizations, depending on how the logs look and what type of resources the organization has. Lastly, all organizations should have an incident response plan for all the applications it is using, and this should be looked at least yearly to make sure that any breaches are found easily and effectively and keeping all of their consumers' data protected. I've only gone over 4 of the 10 most critical web application security risks. The other 6 are sensitive data exposure, XML external entities, security misconfiguration, cross-site scripting, insecure deserialization, and using components with known vulnerabilities. For the ones I did go over, I've also only given a relatively short summary of all of them. If you'd like to look more into these security risks, I've provided the link to the most recent OWASP report on this slide, where I got most of my information. A new one is made every 3 years,
So a more up-to-date one should actually be out this year. So we can see if anything has stayed consistent or anything may be off the list now that the organizations are more aware of these risks. And that's all. Thank you so much for listening, and we'll catch you all next time.